Okay, folks, this right here is chapter 8. All right, if you're good at this, then you've been paying attention this chapter. Okay, y-intercept. Very simply put, that's given, basically, right? If you know where you're looking, it's given. The y-intercept is 0, -5, and the reason is because if we plug in 0 for the x's, all that's left is that -5. So 1, 2, 3, 4, 5. We'll put a dot right there, and we're in business. Now to find x-intercepts, to find the y-intercept, we plug 0 in for x. To find the x-intercepts, we're going to plug 0 in for y. And when we do that, it should hopefully start to look familiar, because we've spent a lot of time factoring problems that look like this so that we can solve. And I've talked about the fact that with a 1 out in front of here, we can go straight to our diamond that produces instant factors. And if we know it's equal to 0, this should be easy enough to solve. So the -5 is going to go on top, the -4 goes on the bottom. The two numbers are multiplied together to get this, add together to get that, are -5 and +1. Okay, again, those are the factors, those go directly in. The reason we can do the shortcut version without the box is because I've got an x squared, which is the only thing that could make that 1x squared what it is to have an x here and an x there. And if there's no question about a coefficient in front of either of those, then it has to just be x. So then these become the rest of the factors. So that -5, we'll put that right here. That +1 or +1 is going to go there. Okay. If I turned around and foiled this thing, I'd end up with that equation right there. But I don't want to. I just got here for a reason. We're going to use the zero product property to solve for x. Okay. Take x + 1 equals 0. Subtract 1 from both sides. I got x equals -1. And this guy over here is already set equal to 0, so if I add 5 to both sides, I got x equals 5. So these are our x-intercepts. We have an x-intercept at 5 and at -1. 1, 2, 3, 4, 5. And at -1. Now I probably should have taken a closer look at this scenario. The vertex is going to be in between. It's going to be way down below. We're going to have to extend this thing. Fortunately, we have space for that. Okay? But if I have a point at -1 and a +6 or +5, there are 6 units separating them. Okay? From here to here, if I kind of look and see this, I've got the halfway point is going to be where my vertex is located. So vertex is going to be right there in the middle, and if I count it out, 1, 2, 3, 4, 5, 6. Half of 6 is 3. 1, 2, 3. I'm at that spot right there, which happens to be 2. So I can look at that and know my vertex, the x value of my vertex is equal to 2. If I plug that in, I can solve for, I can find out what my y value is for the vertex. Okay, and so if I go back to this point right here, I can plug it in anywhere, even the original. Let's go over here and do that. If I plug that in, I got a 2 squared -4 times 2 -5. Again, the point is we found that the vertex is going to be right in between those 2 points. So we're plugging in that value, which we've counted over from 0 is 1, 2. You plug it in here, you've got a 4. That's an 8, -8, and then -5. So 4 minus 8 is -4, -5 is -9, so -9 is the other part of my vertex. And foolishly, no, not so foolishly, 1, 2, 3, 4, 5, 6, 7, 8, 9. I used my graph space to find my vertex. Let's use some symmetry to get one other point. From this point to this point, I went down 5 and over 1. The same thing's going to happen here, down 5 and over 1 the other way. And right there you have a pretty good number of points. You could get a couple others, but you definitely have enough to get a pretty good idea of what that thing's going to look like. How many real solutions does the graph have? Talking about real solutions is another way of saying how many roots or how many x-intercepts. There are 2 real solutions, and that was chapter 8 in a nutshell.